All right, hello, good morning, welcome. We're going to be doing day three today on lesson two, loans. All right, so we're doing loans. It's unit two. All right, we got three learning targets. On day one, we did a lot of this. I can read monthly payments from a table. So hopefully by now, by day one, you're able to start reading, figuring it, being able to calculate monthly payments based on that monthly payment table. All right. Number two is what we're doing today. Learn target number two is what we're doing today, which is I can compute monthly payments using a formula. Now, the monthly payment formula, it's a beast. It's a monster, but we're going to take it one step at a time. I'm going to show you two or three different ways of getting it done, and we'll get it done. All right. It's difficult. It's more difficult than the quadratic formula, which I know how you guys all love that much so much. So yeah, so that's what we're doing today. Day three, we're using that monthly payment formula, and then the third learning target is I can compute finance charges on a loan. We did a lot of these on day two. Day two was the finance charges. So remember, whenever you take out a loan, say you take out a loan for $10,000, you have to pay back all $10,000, and then you'll find that if you add up all your monthly payments plus your down payment, it's going to be more than 10,000. It's going to be 11,000, 12,000, something like that. What's that extra money for? That's the finance charge. That's the interest. That's the money you pay for the privilege of borrowing someone else's money for a short time, right? Or for a time. All right, well, we went over the vocabulary in day one. If you want to go over any of this vocab, look at the day one video. You're going to want to put your name here where it says your name, all right? Where it says your name, you're going to want to put your name. If you want to review what topics we're doing possibly in this unit, if you want to look at our plan of study, we're on loans for lesson two. We have, let's see, probably 3 or 4 more weeks of loans to do, and then we can look at automobile ownership. All right, so probably in quarter three, we'll be doing some automobile ownership. Click on next. Click on next right here, that little next button, which will take you to the questions for day three. Oh, I got to click on this and then make that go. Okay, there we go. This is our day three, and voila, here we are. The monthly payment formula. This is it, folks. This is the beast. This is the monster. All right, the monthly payment formula. So here's our situation. We're going to use this thing. Whew, just take a deep breath, maybe. Sometimes I know some people see a big formula like this and they get a little panicked, a little stressed, a little anxiety. All right, just don't worry. What we're gonna do is we're gonna do the top first, then we'll do the bottom, then we'll take the top divided by the bottom. Voila! All right. Mark bought a new car. Mark bought a new car. The total amount that Mark needs to borrow is $28,716. $28,716. He plans on taking out a 4-year loan, at an APR of 5.12%. APR, annual percentage rate of 5.12%. What is the monthly payment? Now, day one, we worked on how to figure out monthly payment using the table, right? But remember that table only had APR, annual percentage rates, in quarter percentage increments, right? So this is not 5.25%, it's 5.12, which means that table is going to be no good to us. We could approximate a monthly payment using the table. We could use, say, 5.25% as the approximate percentage rate. But the exact amount, we're going to need to use this formula because our tables don't always have, every single increment of possible APR available. So, all right, so let's take a look. This is the monthly payment formula again. Let's take a look what all these little variables mean in here, all right? M, this capital M here. Capital M means the monthly payment, right? If you put all the numbers in all of this, it'll spit out the M, the monthly payment. That's why it's the monthly payment formula. P is principal. P shows up once. It only shows up once in this whole formula. Right here in the beginning, you're multiplying the principal by all of this in the numerator, right? All of this on top is the numerator. All this on the bottom is the denominator, okay? So P shows up once right in the beginning. We're multiplying P by everything else. Then we have lowercase r. Lowercase r is the interest rate. It's the percentage expressed as a decimal out of 1, okay? So 5.12%, we're going to have to move this decimal place over a few. Move over 2, in fact, right? Because percent is per 100%, right? Percent is per 100. So we have to move it over 2 places because we have to make a 100 become a 1, if that makes any sense, right? So I'm going to move this over 1. The decimal moves over 1 place and then a second place, which means this 5.12% becomes 0.0512. all right, just like it is here. 0.0512, 0.0512, right? This decimal place got moved over two places. It went from 5.12% expressed as a decimal out of 1, moved over, that little decimal point moved over two places, all right? Not to belabor that point, but this is one of those common errors, common mistakes that students make, so I want to just spend time explaining what's happening here between the 5.12%, how it suddenly becomes 0.0512. If you have a difficulty moving that decimal place over two places in your head, just take this 5.12% and divide by 100. All right, so let me show you how that works. 5.12. Oh, my calculator's being funny. It wants to be super big. No, come on, calculator. I don't want. There we go. 5.12 divided by 100. All right, I'm converting the percentage into a decimal, dividing by 100, and 0.0512. If I wanted to convert this back, I'd multiply it by 100. Right? Multiply by 100 undoes my dividing by 100, and I get my same number back, 5.12. All right, very good. All right, now R is the interest rate. Now, R shows up three times. It shows up here, it shows up here, and it shows up here. It shows up twice in the numerator, once in the denominator. And then T. T equals the number of years. T equals the number of years. T shows up twice in this formula. It shows up as an exponent of this piece right here. This exponent right here is raising all of this in parentheses. This piece right here in parentheses is raising it to 12 times T, right? And why is it 12 times T? Well, T is the number of years, and 12 is how many months there are. 12 is how many months there are in 1 year. So if it's a 4-year loan, I'm going to put a 4 in for T. 12 times 4 is 48. I'm going to raise all of this in parentheses here to the 48th power. All right, raised to the 48th power. And then T shows up again down here, right? And it's still 12 times T, right? 4 years, 12 times 4 is 48. So I'm going to raise all of this in parentheses, this piece right here, raised to the 48th power. All right. Now, fortunately, we're not going to have to raise things to the 48th power in our heads or on paper. We're going to use our calculator for all of this. But the thing is that this is such a big monster that we have to be really careful on how we put it in our calculator. And I'm going to show you how that happens. All right. So let's go back to Mark and his new car. He borrows $28,716. It's a 4-year loan, APR of 5.12%. All right. We're going to use this formula and we're going to substitute in all of the different variables, right? His P equals $28,716, right? That's the principal, right? 28,716, principal, P. R, that's the 5.12%. That's going to be changed into a decimal out of 1, 0.0512. Remember, it's just a 5.12 divided by 100. And then lastly, T. T is 4. T is 4-year loan, okay? Now that I have my variables, I have to plug all of these variables into this formula, and here's what that looks like, right? P becomes $28,716, right? That's the principal. Then I need to have R divided by 12. That's my rate divided by 12. 0.0512 divided by 12. All right. And then R has to go in here where R is 1 plus R divided by 12 again. 1 plus R, 0.0512, sorry, divided by 12. All right. That's 1 plus my rate divided by 12, raised to 12 times T. 12 times T. Well, T is 4, so 12 times 4. All right. And then I go to my denominator on the bottom. I have to plug in my rate. My rate has to be plugged in down here, 0.0512 divided by 12, so it's 1 plus my rate divided by 12, raised to the power of 12 times 4, which is 48, right? 12 times T, and then this is all minus 1. Woof. Okay, that's the whole thing. One thing you can do, the next step here, this step here is exactly the same as that above, except for they actually just multiplied 12 times 4 to raise things to the 48th power. All right, and so this is what the whole thing looks like if you rewrite it all on paper. And here is what it would look like kind of in your calculator. What I don't like about this, the one tricky thing is this minus 1 at the bottom. So keep in mind, keep in mind that when this piece gets raised to the 48th power, just what's in parentheses here, right? And then whatever this comes out to be, we subtract 1 from that. All right. But what this looks like, it's almost like 48 raised to the 48th power minus 1, which would be raised to the 47th power. So it's kind of deceptive. The calculator knows actually how to do this and won't make that mistake. But yeah, that's one little kind of thing to kind of keep your eye out for. So here I go. I am going to try to do this whole monster in the one shot, like shown right here. So this is one way of doing it. It's called the one shot. You do the entire formula all at once. I don't recommend this one per se, but if you like it, if you like the idea, then go for it. Okay. Notice how you have to do it exactly like this. All right, it has to look pretty much exactly like this. I'll show you any differences on your calculator. Hopefully, you all know how to get this TI-84 Plus Silver Edition Wabbit EMU on your Chromebooks. If you don't know how to do this, go to Rock Connect, and log in, and then you should have a little thing which will install the Wabbit EMU on your Chromebook, okay? And Rock Connect. All right, I have to open with a parentheses, right? Because what's going to happen here, you see this little symbol right there? That's the division symbol. That's this bar here, right? And I want to calculate everything in the numerator first and then have it divide by everything in the denominator. So this parenthesis here and this parenthesis here is taking encapsulating this whole numerator. My numerator is all of this, right? It's all of this up here being captured in one piece. So I need this parentheses here. That's important. $28,716. That's Mark's principal. I'm just going to use another parenthesis because there's going to be an implied multiplication between the 28,000 and everything that comes after the parentheses. All right, it's implied multiplication. If you would like, you could do times parentheses if that makes you feel better. But the calculator knows that there'll be an implied parenthesis. That a parentheses there means implied multiplication. 0.0512. I'm putting in the rate expressed as a decimal out of 1 divided by 12, right? I'm doing this r divided by 12 piece right here. There's my rate divided by 12. I'm going to close that off that parentheses. These two parentheses just capture this little division operation right there. And then I'm going to use another parentheses. Again, the implied multiplication between parentheses. All right. If you want to use a multiplication symbol, you're welcome to do so. It's not necessary here. 1 plus. Now I'm doing this piece here. 1 plus my rate divided by 12. So my rate, 0.0512 divided by 12. All right, 1 plus my rate divided by 12. I'm doing this piece right here. I'm closing off that parentheses, and then I'm going to raise this to the power of 48. Caret raises it to the power of 48. So I pressed the caret button to get it up here to 48. All right, and then this is very important, I need to press the right button. See how my cursor is kind of up in the exponent kind of area? I need to drop it back down, get us back into the regular part. All right, so you got to press this right button to go from the cursor drop from the exponent. If you do everything back in the exponent, it's going to do crazy stuff. It's going to do all sorts of crazy stuff to your exponent. That's not what you want. Okay, now that I've dropped my cursor down, I want to drop a new parentheses. Remember that first parentheses we started? We're going to encapsulate the entire numerator here. And notice how that parentheses is a lot bigger. Let me show you what it looks like in the beginning of my expression. Right there. See how the parentheses is much bigger? So this is giving you this idea that the calculator is giving you a visual hint that it's catching everything in the numerator now. Everything in the numerator. And now I need a division symbol. I need this division symbol to go in right there. All right. So I've done my numerator in the one shot. That's done so far. I'm going to start with another parentheses to capture the entire denominator. I need yet another parentheses in there because now I'm going to capture this little piece here, 1 plus my rate divided by 12 raised to the 48th power. All right, so 1 plus my rate, 0.0512, divided by 12. Now I'm going to close this parentheses off, capturing just this 1 plus my rate divided by 12, and now I need to raise that to the 48th power, right? Raise that to the 48th power. Using the caret button, go into the exponent range, 48. I'm going to use the right button here to drop my cursor back down. That's super important. All right, super important to drop your cursor back down at this point because I want a -1, and I need that -1 to happen down here. Right? I need this -1. I do not want, I'll show you what I don't want. This is not what I want. I don't want 48 -1 there because then it'll raise it to the 47th power. That's not what I'm looking for. I don't want to raise it to the 47th power, just to the 48th power. All right, so I've got my -1, and now I'm going to close the parentheses off, encapsulating the entire denominator. And let me show you that my parentheses on the beginning got bigger. It got bigger there it is. There's my parentheses to start my denominator, and there's my parentheses to end my denominator. And now when I press enter now, I'm going to cross my fingers because this doesn't always work. If I made one mistake in here, things won't go well. But if I did everything very carefully, drum roll please. Okay, it worked out. It worked out. All right. $662.87, right? $662.87. That is going to be Mark's monthly payment on a loan of $28,716 with a 4-year term, a term of 4 years with an APR of 5.12%. That's the one shot, folks. That's how you do it all in one shot. If you like risk, if you like the fact that if you're very careful, if you're a very careful person, very methodical, meticulous, the one shot could easily work for you. I'm not saying you can't do it. I'm just saying that there's a little bit room for error that you might not want. You might not want. I'm going to show you what I'll call the Mr. Salt way, which is doing my way. My preferred way is I do the numerator all at once, find the answer for the numerator. Then I do all the denominator all at once and find the answer for the denominator. And then I just take my numerator, divide by my denominator, and then I get a final answer. The nice thing about this is that if you mess one up, you can fix them a little bit easier. And so that's like the advantage is that there's a little more room for error, a little easier to fix. To me, it just makes more sense. So the question here is find a monthly payment for a $1,000 loan at 1 year with an APR of 7.5%. All right, $1,000, 1 year, APR of 7.5%. And here's the formula. Oh, and I'll never ask you to have this formula memorized. All right, just take that stress right off your head. I'm not going to ask you to have this formula memorized. Anytime I want you to use this formula, I'm going to show it to you just like this, right? I'm going to show you the formula here, and I'm going to give you what each variable is, so you don't have to have this formula memorized. But I would like you to be able to at least, once, twice, 3 times in your high school career, if you're taking a class called Advanced Algebra with financial applications, I want you to at least once, twice, 3 times be able to have actually calculated the monthly payment formula, like kind of manually with your calculator. All right. It's kind of a rite of passage. I look at it that way. In real life, we don't do this by hand on our calculators. I'll show you 2 different ways to do this in a much easier way. One using your calculator, really easy, and another using spreadsheets, even easier to find the monthly payment formula, where you don't have to do all this mess. You can literally just say, "Here's my principal, interest in years. Calculate my monthly payment for me. Thank you." All right, but right now, I want you to do it kind of manually using the calculator, just so you understand kind of what's going on behind the scenes. All right. So this is kind of like where I would normally let you have a minute or two of think time to do this, but I'm feeling like this is so new and this is difficult, so I'm gonna show you this one. I'm gonna show you. I'll give you some think time in the next one. I won't even encourage you to pause right now. All right, so I'm gonna do the numerator first. All right, so I got p times my rate divided by 12. I'm gonna start with this piece here. So because I'm doing it in my numerator first, I don't need parentheses or anything. I'm just doing just the numerator first. 1,000, that's my p, that's my principal. My rate divided by 12. My rate is 7.5%. I can convert that in my head to 0.075. If you can do that too, great. If you can't, take the percentage rate and divide it by 100 to find out what the decimal would be as a decimal expressed out of 1. Now I do need to do 1 plus my rate divided by 12. 1 plus my rate divided by 12. All right, so now I got this piece. Close that parentheses. Raised to the power of 12 times t. T in this case is 1, right? 1 year. So it's just going to be raised to the power of 12. All right, at this point, I'm just going to press enter, right? Because I'm doing that's my numerator. That's what my numerator equals. All right, that wasn't so bad. Now I'm going to do my denominator. 1, I'm going to use the parentheses. 1 plus my rate divided by 12, 0.075 divided by 12. Close the parentheses. Raise to the power of 12 times t. T in this case is 1, so I'm just going to raise it to the power of 12. Raise to the power of 12. And then I'm dropping that cursor back down using the right button, right? Minus 1. I'm going to find the denominator now. That's the denominator, all right? Now that I have the numerator and the denominator, it's this easy. I press up until I find my answer for my numerator, and I press enter. Now I have my numerator brand new spanking new in my in my this part. I don't know what to call this. In the right up front in the calculator, right? I'm going to press divide right now, and then I'm going to go up again, and there's my denominator. I'll press enter. So notice how it just stuck my denominator in, and just to show you, there's my denominator, there's my division symbol, and then there's the numerator I had from before. When I press enter right now, it'll calculate the numerator divided by the denominator. Boom, right there. There's my monthly payment. This is kind of like a three-step process, right? First, calculate the numerator, then calculate the denominator, then take the numerator divided by the denominator, right? And then you have your monthly payment. So $86.70. Oh wait, I have 7.757. This is a financial problem, so I need to round this to the nearest cent, right? So the 7 here in the thousandths place rounds this 5 here up to a 6. So I have $86.76. And I choose that right there, $86.76 as my response for that question. All right, so this one, it's the exact same problem you just did a second ago, except now the change is there's a 2-year loan. A 2-year loan. This is now where I'm going to encourage you to pause the video and actually do this on your own for practice. All right, so pause the video now and get yourself some practice. Pardon me. I have hope. I sincerely hope you gave yourself the opportunity to practice this on your own, right? Because I know that the temptation is to look at this stuff and say, oh, I can learn by just watching. You can learn by just watching, but you learn even more by doing some doing, all right? You learn more by doing than you do by watching. So, all right, here I go. I'm going to do, let me show you Mr. K's way. Let me show you Mr. K's way. This is Mr. K's way. I like it. It has a lot to recommend it. All right. So there's this thing. If I press this green alpha button, I get this little cursor that goes A as alpha, and if I press the Y equals, I get a menu that looks like this. This N over D thing, that's the calculator's way of saying, hey, would you like me to put this in the form of numerator over denominator? Yeah, I would, calculator. I would like you to do that for me. All right, so that was alpha Y equals green Y equals gave me this right here. Right, I'll show that to you once more. Alpha Y equals. I want the N over D. I press enter. Right, and now I have the calculator's giving me this numerator over denominator form. So now that it's almost like I can do it just like the formula shows, right? P is 1,000 divided by R divided by 12. That's 0.075 divided by 12, right? Times parentheses 1 plus my rate divided by 12, 0.075 divided by 12. Close the parentheses. Raised to the power of 48. Oh, wait, no. My bad. 24, right? 2-year loan, 12 times 2 is 24. Raise the power of 24. All right, raise the power of 24. And notice I'm kind of like, without even thinking about it, I'm already dropping this cursor back down where I want it. But now I'm done with the numerator, so I need to get to the denominator. I'm going to press the down button to get down to the denominator. There I am. I'm now down at the denominator. Now I'm going to do 1 plus the rate divided by 12. 1 plus the rate, 0.075 divided by 12. All right, closing that parentheses. I want to raise this to the power of 24. So caret 24, right? I'm pressing the right button to get it bring that cursor back down where I want it, and then -1. And if I did my job here, this should give me my monthly payment, right? So maybe you like this method where it's set up just like the formula. There's a lot to recommend it. I like the fact that it looks just like the formula. I like that it's a kind of a combination between a one-shot and my method, right? You're kind of doing the numerator first, then you're doing the denominator like my method is, but it does it all in one shot, which is also the advantage. Sorry, that's my motion detector going off, telling me that there's someone at the front door or something. All right, so 44.9995, right? So we have to round this to the nearest cent, right? This 9 in the thousands place rounds this 9 up to a 0, which rounds that 9 up to a 0, which rounds this 4 up to a 5, which gives me 45.00, right? That's the monthly payment for this 2-year loan at an APR of 7.5%. Oof. Okay. Um, Find the monthly payment now for I suggest you give this a shot. Find the monthly payment for a $10,000 loan at 2 years with an APR of 7.5%. Pause the video here and give this a shot. All right, I hope you paused the video. I hope you gave it a shot. Do you remember the table where it had in fact, these particular problems could be easily solved by that table, right? If you had the table in front of you, you could easily calculate these monthly payments without the monthly payment formula because these percentage rates are, easy percentage rate, 7.5. That's on the table. Well, remember how you would have to find the term, how many years the loan was, and you have to find the APR, and it gave you the monthly payment for $1,000 of loan of principal, and that if you borrowed, say, 20 times that amount, you'd have to multiply that monthly payment by 20. Well, here's a situation where between this problem and this problem, the only thing that changed was the loan amount, and it times 10, right? It went from 1,000 to 10,000. So if our last answer was $45 even, then we could actually anticipate that our next answer is going to be $450 even. It's going to be the monthly payment is going to be 10 times bigger because the principal is 10 times bigger. So let me just show you how to do that. In fact, I'm going to use this. I'm going to use this. Did you see what I just did there? I want to make sure you know how. So I already figured out. I did this a one shot of this formula for $1,000, and I can go back and I can find that using the up button. I can find the history. Once I have it selected, I'm going to press enter. All right. So this is the exact same problem over here. The only difference is it's $10,000 and not $1,000. So I'm going to press the left button until I get over to my principal, 1,000, and I'm going to insert. See this INS? That means insert on the calculator. INS, it's in blue right above del. All right. I'm going to press second del to insert an extra zero here. I've just inserted an extra zero, and my 1,000 became 10,000. So now everything else of this whole problem is the same, which means I don't need to change anything else. I can just press enter. And look at that, $449 and 9959. All right, so now this 5 rounds the 9 up to a 0, which rounds that 9 to a 0, which rounds that 9 to a 0, which rounds that 4 to a 5. So I get $450 even. $450 even. That's my response to this guy right here. A $10,000 2-year loan at an APR of 7.5%. Woof. All right, this is the last one. Find the monthly payment for a $25,000 4-year loan with an APR of 6%. I've changed everything on you. This one, you pick your favorite method. You can choose the one shot with the example right here, right? You can do the one shot. Remember, that's the only tricky part is bringing that cursor down from raised to the 40th power. You can do the one shot right here. You can do my method, which is to do the numerator first, then the denominator, like we did in this problem right here. You can use Mr. K's method. Oh wait, no, this is the one we did the numerator then the denominator. You can use Mr. K's method, which is pretty cool, right? It's got the numerator denominator. Right? That's alpha y equals. To get this alpha y equals, get you that numerator denominator thing, so you can kind of do them separately. All right. However you'd like to do this last one, you choose the method and do this one, and then go down here and press submit. All right. Oh, answer some of these learning target questions. Tell me how you're doing on reading monthly payments from the table from day one. Are you completely, mostly, kind of successful? Tell me how you're doing with this monthly payment formula. This is the one I'll be looking at mostly today. Just tell me your comfort level. If you're not feeling successful, click not successful. That's fine. If you're still confused, if you got the right answer once or twice on your individual practice, do kinda. If you're getting them all right, then completely. It's all But this gives me an idea where you guys are at and how much more practice you need. And then I can compute finance charges on a loan. Remember, that's however, if you add up all your payments and however much that is greater than how much you borrowed, that's your finance charge. Tell me how comfortable you are with that learning target right there. Give me your level of effort and don't forget to click submit. Click and submit is the magic button, which records your response, which saves your work, which allows me to grade what you're doing. All right, and I'm grading these things every day at the end of the day. So just get your don't. I mean like I'm not going to penalize you for turning in anything late, but I also don't want you to procrastinate. There's too much procrastination going on, and it's hurting you. All right, you're your own worst enemy when you do that. So don't do that. Just get it done. We like in class we'll do most of these, for the first few days, and so it shouldn't take you any time to do that one last problem up, right? So please just get this stuff in. We need to pump those numbers up. We need to have evidence of learning in the grade book. Okay. All right. So this is Mr. Solt signing off. Have a great day. I'll see you in class.